Welcome, everyone. We're in topic 7 today. And topic 7 really is stoichiometry. Stoichiometry is just a fancy word that means the math of chemistry. And in this portion of stoichiometry, we're going to learn some tricks and some hints to help you balance some equations. Before we learn anything about balancing equations, I do want to go over a couple of terms that you should already know, just to refresh your memory. So the first term that I want to go over really is chemical equation. Now, what we have in front of us right now is one chemical equation. So this whole thing is known as a chemical equation. Now, often when we speak, we dump the word chemical and we just say this is an equation. Oftentimes you'll see me shorthand equation as EQN. That's the shorthand for equation. Now, within every chemical equation, there can be many chemical formulas. So in this chemical equation, I have a formula here. I have a formula here. And I have another one here. And formulas can be compounds, can be molecules, can be elements. What it really is are just the symbols that represent our elements, and it tells us how many. Now, in addition to looking at the whole equation and looking at the many formulas that make up the equation, you should also know that in the forward reaction, that there are always reactants and products. And in the forward reaction, our reactants are always left of the arrow. And in the forward reaction, we always have our products to the right of the arrow. Okay. Now, two more terms that are also very important to us before we start balancing equations. We have the word subscript versus coefficient. Now, let's look at the word subscript first. In this one chemical formula, I actually have many subscripts. You only see one so far, but remember that there's an unwritten 1 next to the potassium and also another unwritten 1 subscript next to the chlorine. So in this one formula, we actually have 3 subscripts. Subscripts are always going to be right of the element symbol and also below the line. Remember that you do not have to write the subscript of 1, but you should know that it's there. And the last thing to remember is that subscripts really tell us how many atoms are present. So from this formula, I know that there are 3 atoms of oxygen, 1 atom of chlorine, and 1 atom of potassium. Now, coefficients, on the other hand, are going to be in front. So there is always an unwritten coefficient of 1 in the front of this whole formula. And not only is it going to be in the front of the formula, but it's also going to be written on the line. It's not below the line, but it's on the line. To remind you as well, or to tell you as well, is that there can never be a coefficient of 0. There's no such thing as a coefficient of 0. There's always that 1 that's in there. And what coefficients really tell us is how many of the whole formula. So by putting the coefficient of 1 in front of here, it tells me I have 1 KClO3. Now the coefficient can act as a multiplier. So if I change my coefficient, so now I have this same formula, but I've changed my coefficient to a 3, it acts as a multiplier. And it first tells us there are 3 KClO3s. There's a 3 total of that formula. But it also tells us how many and acts as a multiplier. So that 3 gets carried to here, and then all the way to the oxygen. So if I wanted to know the total amount of atoms with the coefficient in front, then it becomes 3 potassium, because there's a subscript of 1, 3 times 1. I have 3 chlorine as well. And then the oxygen, it's the 3 coefficient times the 3 subscript, so I actually have 9 oxygen. So be aware that the minute I put a coefficient in front of a whole formula, I can actually change the number of atoms I have as well. The last thing to remind you about is that coefficients are the only thing that can be changed when balancing equations. You may never change a subscript. A subscript is specific and is really there based on the octet or based on the stability of this compound or this formula. So we are never going to touch a subscript, but we can always change our coefficient. All right, so let's take a look at some sample problems. Now, this is the first sample problem. I have a whole chemical equation in front of me, and the first thing to remember is that you must always have the law of conservation of mass on your mind. And by definition, the law of conservation of mass says that mass cannot be created, nor can it be destroyed. In a simpler format, which helps us actually balance our equations, is really whatever we put in, it has to equal what we put out. Or even more simple, my reactants must always equal my products. If my reactants do not equal my products, then I have to balance my equation. That's the point, because we never want to break the law of conservation of mass. So to start everything off, the first thing that we're going to do is we're really going to separate our reactants from our products. So wherever that little yield sign is for my equation, I'm going to split it into 2, because I have to get my reactants equal to my products. After I've done so, now I want to do some bookkeeping. I want to know how many atoms of each are there. I'm going to remind you that in front of each of these formulas, there's an unwritten 1, and you don't have to put the 1, but for now I'm just going to put it there. And when I do that, then that means that 1 multiplies across each of the element symbols. So when I bookkeep on the reactant side, it says that I have 1 potassium, I have 1 chlorine, and I have 3 oxygen. So I just took a total or a count of what's on my left side of the arrow. Now I want to do it the other side, just to see if I'm balanced already or if I need to change some coefficients. So I'm going to keep things in order. So K, I have 1 of them. Chlorine, I have 1 as well. And now watch what happens with the third formula. For my oxygen, I actually have 2. Now if I take a quick scan, I see that my potassium is balanced, 1 on the left, 1 on the right. My chlorine is balanced, 1 on the left, 1 on the right, but it's my oxygen that I'm having a problem with. So that's where I'm going to start to worry about balancing my equations and changing my coefficients. So here's my problem. These numbers are not balanced. Now, as a hint, you should always start on the side that has less. So on the right-hand side, I have 2 oxygen. On the left-hand side, I have 3 oxygen. So I'm going to start here on this side. The first thing I'm going to do is I'm going to change my coefficient. I have to change it to some number in which I can even out the number of oxygens on the left-hand side. Now 2 and 3 don't evenly match, so I need to come up with a common number. And if you are lost, you can just change the coefficient to 2 and see what happens. But I know that the common number between 2 and 3 happens to be 6. So by changing this to a coefficient of 3, I now can somehow get it to balance. But listen carefully. Before I move over and see if it's balanced, I want to change my bookkeeping or my counting. By putting a 3 here in front of the O2, this now will change my oxygen to 6. All right, so now I go to the other side. I want to balance it off. So I need to change the coefficient in front of this formula. The only way I can get oxygen to balance is if I put a 2 in front of here. But be careful. Before I do anything, I want to take account of what I have. By putting a 2 in front of this formula, it now changes potassium to 2, it changes chlorine to 2, and now oxygen ends up being 6. Now I have to double check again. Once I've done that, I'm going to check where my problems are. Oh, potassium is no longer balanced. Chlorine is no longer balanced, but I did a good job with oxygen. So you're constantly going to have to be checking from left to right of the arrow. So you're going to check your reactants, check your products. Now that I messed up potassium and chlorine, I have to go and fix it. And the rule, or the hint, is to go to the side that has least. So if I start with potassium, it has only 1. What can I do to this coefficient? So if I'm lost, I'll just go up one number. I put a 2 in front of here. Before I leave my product side, I have to make sure that I change my totals. My potassium becomes now 2. My chlorine now becomes 2. Now I'm going to double check. Is everything balanced? Potassium 2 on the left, potassium 2 on the right. Chlorine 2 on the left, chlorine 2 on the right. Oxygen 6 on the left, oxygen 6 on the right. So this formula is now balanced with the coefficients of 2, 2, 3. All right? So, and I followed and I kept my law of conservation of mass because now my reactants always equals my products. And this is a constant back and forth between your reactants and products and constantly changing your coefficients. Okay, so now let me show you another sample problem. And this happens to be a shortcut with polyatomic compounds. What happens is this formula or this chemical equation is actually very large. But there is a shortcut that you can use in order to make it a little bit easier to balance. If you find that somewhere in your equation you have a polyatomic ion that does not change from reactants to products, then you can actually lump these together. So you'll notice that in my formula, NO3 stays NO3 on the left and it's NO3 on the right hand side. So I can utilize this shortcut. So now watch what happens. I'm going to do the same thing I did before. I'm going to split my reactants from my products, and then I'm going to do some bookkeeping. I'm going to see how many I have of each. So for aluminum, I have 1. And remember, there's a coefficient of 1 in front of all of there. For PP, I have 1, and watch what happens. NO3, because it doesn't change from reactants to products, I lump it together, and I see a subscript of 2, so I'm going to put a 2 in front of there. There's 2 NO3s. Now I'm going to work on my product side. Aluminums, I have just 1. NO3, I'm going to lump it together. I have 3 because there's the subscript of 3. And then PB, I have 1. And I kept the same order just so I can visually see what's different and what's not different. I noticed that in this problem, I have the NO3s that are not balanced. That's my issue. My aluminum and my lead happen to be balanced. But I want to make sure everything is balanced. So I'm going to do the same thing that I did before. I'm going to go to the side that has the least amount. So I'm going to start with this 2 right here and this NO3. And I'm trying to figure out what number I can put in front of here to make it even. And once again, I have a 2 and a 3. They're odd, but I know the common number happens to be 6. So by changing this coefficient to 3 in front of here, I now have to go back and change my bookkeeping, or change my totals. By putting a 3 there, it makes my lead now 3, and my NO3, I already have a subscript of 2 times the coefficient of 3, that makes that 6. Now, I want to fix my NO3s because that's what I'm working with. So now I'm going to go to my product side. By putting a 2 in front of here, I now need to check my totals. My aluminum becomes 2, but my NO3 ends up becoming 6. The 3 subscript times the 2 coefficient gives me a 6 total of NO3s. All right, if I scan it, okay, I fixed NO3, but I made a problem with aluminum and I made a problem with lead. So now I have to go back. So I'll work with aluminum first. Aluminum is less on the reactant side, so I'm going to work on the left side. And if I put a 2 in front of this aluminum, I can change that total and I can make it equal to that side. All right, I fixed aluminum. Now I need to fix lead. Lead is 3 on the reactants and 1 on the product side. So I'm going to work on the product side. If I put a 3 in front of here, I now change that total to 3. And if I double check, am I balanced? 2, 3, 6, I'm completely balanced. So this equation is now balanced with those coefficients. And this is a shortcut you can use with polyatomic compounds. Now, if perchance you have polyatomic compounds that do change from the reactant side to the product side, then you can't use that shortcut. So let's take a look. In this problem, I see SO3. That's my polyatomic compound. But if I scan to the right-hand side, or my product side, I don't see SO3. I see SO2, but I don't see SO3. Because I don't have the same polyatomic on both sides of the arrow, then I have to separate every single element. They have to be separated. So I'm going to do the same thing I've always done, but I can't use the shortcut now. So I'm just going to do my bookkeeping. I have 2 sodium. I have 1 sulfur. I have to separate it. Oxygen, I have 3. Hydrogen, I have 1. And chlorine, I have 1. Now, let's look at the reactant side or the right-hand side. Sodium, I have 1. I'm just going to keep the order the same just so I visually can see it. Chlorine, I have 1. Hydrogen, I have 2. Oxygen, be careful. Oxygen, there's actually 3 of them. And also, finally, sulfur happens to be 1. All right, so I have a couple of problems here. My first problem is that sodium is unbalanced. And also hydrogen's unbalanced. So here's my next hint. When you're faced with several things to balance, you always want to balance hydrogen and oxygen last. In this case, oxygen happens to be balanced, but hydrogen's not balanced. So I'm going to work with the sodium first. So same rules apply. The sodium with the lesser amount is the side that I'm going to start on. So I'm going to start on the right-hand side. And I'm going to have to change that one unwritten 1 coefficient in front of NaCl. So I'm just going to change it to 2. By putting a 2 in front of there, I now have to change my totals. I have 2 sodium, and now I have 2 chlorine. So I fixed my sodium problem, but I made a chlorine problem. All right, and my hydrogen is still off. So I'm not going to touch my hydrogen yet. I'm going to still work with something other than hydrogen and oxygen. So if I want to fix my chlorine, I have to go to the right side because there's only 1 chlorine on the right side and there's only 1 chlorine on the left side and there's 2 on the right. So we're going to work on the left side first. Now to make it even, I'm going to put a 2 in front of here, but now I got to change all my totals. So now hydrogen becomes 2 on the left side and chlorine now also becomes 2 on the left side. Now, am I balanced? 2, 1, 3, 2, 2. Everything's balanced. And you don't have to, but you can if you want to. You can write in the 1 coefficients in front of each of the formulas. So this formula is balanced with the coefficients of 1, 2, 2, 1, 1. Okay? Now, last thing to kind of remind you of or make you aware of. The questions that you're always going to encounter says balance the following equation using the smallest whole number coefficients. And this is standard. People can balance with decimals or half numbers, but in this course you're not going to. You're always going to use a whole number, and it has to be the smallest possible numbers. So the formula that I have on this page technically is balanced. And if we wanted to make sure we can see, if I did some bookkeeping, I actually have 6 nitrogen, and my hydrogen, I have 18 on this side. On my product side, I have 6 nitrogens, and I also have 18 hydrogens. So yes, technically it's balanced, but it's not given in the smallest whole number coefficients. So be aware, You might have it balanced, but you still have to reduce it down. So every one of these coefficients has to be reduced down by the same number. So if I divide by 3, which is common to all of these coefficients, this now becomes properly balanced 1, 3, 2. This is the correct answer. Yes, the coefficients of 3, 9, 6 worked, but according to all the questions that I'm going to encounter, I want to have the smallest number. So take a look when you're done to make sure that you cannot reduce down all the coefficients. And you can't just reduce one. If you're going to reduce them down, you have to reduce all of them. Not just 2 of the 3, not just 1 of the 3. All 3 must be reduced down, or all of the coefficients, whether there are 10 of them, have to be reduced down by the same number. Okay, that's it for now. I'll see you in the next lesson.